I'm going to talk about a JV that is actually being built right now in Kingdom of Saudi Arabia. It's between Dow Chemical company, which is what I work for, and the Saudi Aramco company. And I'm going to talk about a little bit about the JV itself, give a context of what's going on over there, and then what is it that we are doing in our role to make the challenge come to fruition. So the JV is called Dow Chemical Company, and Dow basically is constructing, even as we speak, and they'll own and operate the world's largest fully integrated petrochemical complex in Jubail. It's in the eastern province of Saudi Arabia. And when it's done, I mean, it's the biggest petrochemical complex ever to build in a single phase ever. So it's a massive construction site right now. And our challenge is to actually build the systems, both the enterprise systems and the manufacturing operations systems, and integration with the controls layer. And the JV actually has engaged the Dow Chemical company as the system integrator. So this is a big project. It's been going on for a couple of years. The construction began in third quarter 2011, and the plant would start up with the first product early next year and full production 2016. It's Jubail on the eastern province is an exciting place. Actually, a lot of people don't know about it, but these are the companies that are already out there. Some of them you already know. Some companies are actually here, and there are big refineries and petrochemical complexes all over the town over there, and continuous presence from the government, and the effort to actually diversify the economy is building more and more manufacturing assets in the region over there. A little bit about Dow. It's a science and technology company. It was founded in 1897. We make more than 5,000 products, and we have lots of sites across the globe in many countries. We have large sets of customers, diverse population in terms of our workforce, 50,000 plus, and our sales were $15 billion in 2013. This excludes the JV that I'm talking about. A little bit about the parent company. The other parent company is Saudi Aramco. And we know a lot about them from the fact that they're the world's largest oil company by production. They oversee 20% of the world's known oil reserves. It's one of the largest integrated, most reliable supplier of energy and petroleum-based derivative. So the thing is that the Dow has the science and technology to build to make the chemicals, and the advantage feedstock is going to come from Aramco. And that's where the investment is happening, and the asset is being stood up in KSA. So I'm going to talk about all the stuff that you heard this morning, Internet of Things, all the stuff that Jim referred to in this one picture. This is my slide. I'm going to walk through the challenge that we faced and what did it take to get the systems and the business processes in place in a very short amount of time, a year and a half really, to actually get it ready so that when the assets are coming up over there, they can actually start using it. So at the core, the enterprise architecture, if you look at and I'm going to speak more about the MOM, and I'm going to switch to a different view so you can see it a little bit better. And I apologize, but I'm going to have to scroll back and forth to kind of explain what's going on here. But at the core of the architecture for the Sadara manufacturing operations management systems is based on the ISA 95 reference model. So at the top, you'll see the ERP systems. We saw these pictures this morning from Andy. Jim talked about it. His very last slide actually was basically about this. So at the very top, if you look at it, is the ERP systems that is made up of all the business modules that would support the enterprise in terms of the business applications. Middle layer is the MOM applications, all the systems that the manufacturing would need to support the plant floor as they're producing product. And I'm going to go into a lot more details about that. And at the very bottom, is the controls layer. So this is the puristic ISA 95 model that connects the control systems to the MOM systems to the ERP systems. So if I kind of work bottom up, what the field devices and the IPCS that are in the enterprise over there, are connected to the MOM system via IPCS gateway. It's pretty simplistic. It's puristic model in terms of architecture. And we do have field analyzers that required a bit of an exceptions where we had introduced the OPC servers to connect them to the MOM level application. The middle layer, of course, there is integration that I'm going to talk about in a lot more detail. But if you go within the MOM layer, there is kind of, interestingly enough, two sets of problems. We had a lot of the leverage solutions that we know how to make it work, to solve problems. And they were either interfacing horizontally within the MOM layer, point to point, or we had purchased interfaces, and they're highly reliable. It works. The Dow Chemical company had a vision and does have a vision to actually have a manufacturing enterprise bus at that layer, and they really want to make sure that the platform is stood up and has the right technology in place so they can scale up and down, extensible. And they wanted to introduce the bus so that anything that's new coming in to the MOM layer would first go to the bus architecture. So we have introduced the manufacturing, a true manufacturing enterprise service bus, the MOM layer. If you look at the, I should go here, see if I can. This is the layer that connects the ERP to the MOM systems. This is a bit interesting and more complicated. So there is an enterprise bus here. Manufacturing enterprise bus is here. Enterprise bus sits here that connects the ERP system to the MOM system. And of course, we have a set of interfaces that are either vendor provided, and in the extreme case, we would allow a point-to-point interface, but it's rare, and we don't allow that to happen typically. So that at the highest level is the overall architecture of how the applications are connected. So let me kind of go through the main components of the MOM layer, which is what I'm going to spend most of my time in. There are 5 tracks if I simplify it. The first one is reliability integrity management. The second one is quality operations management. Third one is regulatory compliance management. Fourth one is inventory operations management. At the heart of the whole thing is the production operations management. It sits in the middle of it in the MOM layer, and everything touches the production operations management. So I'll kind of go through the list of how these tracks are interconnected and woven together. The biggest challenge that we've had was bringing the applications that would actually support the requirements, the manufacturing requirements, and instead of just looking at like, hey, this vendor can do that, we actually designed a fully integrated business process hierarchy that actually connects top down. So it would go all the way from the enterprise to the MOM system to the control systems. So for instance, if I start with my reliability and integrity management, typically what happens, it starts on the plant floor when an operator is doing something and finds that, hey, I got a problem. They would write a work request, and the work request would go to the computerized maintenance management system way up in the ERP land. So basically, when that happens, we would have I lost this, the laser. Let me see if I can show here. So the maintenance system would actually get the request, and it would start collecting the cost related to the maintenance, and then it would also have the history of what it takes to fix the problem. And once the problem is fixed, we would actually close the work order. We heard a lot about analytics today. What do you do with all the data? What do you do with all the history? What do you do with all the costs? We actually send that information into the reliability analytics module, where the analytics are happening. The reliability engineers would actually do something with the data, analyze it, create recommendation, and propose the predictive maintenance back to the maintenance system. So that's how the interaction happens. Now, the interfaces are both, in this case, either they go to the bus or they would be the vendor-provided interfaces. The other thing that it does is that it has the light scheduling system and heavy scheduling system, depending on what you're trying to do. If it's a daily or a turnaround scheduling, we would have a pretty robust scheduling system that actually downloads the schedule, and the light scheduling system allows the scheduler to manipulate graphically. The other pieces that makes up the maintenance system is the job packages. We have an automated way of actually aggregating the needed information for the operators or for the scale trades actually. So if the maintenance is required on a specific set of equipment, it would go out, the system would go out and aggregate the right documentation, the procedures, and the drawings to actually do the maintenance, and then it would put it together and print it for the operator, or the skill trade, so they can go and perform their maintenance. So those are some of the key elements for that system that are in place. Again, the interfaces are either the vendor provided interfaces in that module, or we have built our custom interface that goes to the bus. The second big track that makes up the solution is the quality operations management, and the big ticket applications are the lab information management system and the chromatography data system, CDS, and where we have instruments that are connected to the LIMS system, and also the data and the statistical analysis packages are part of that track. Interestingly, we have introduced the portable electronic devices in the field that actually would go ahead and scan the samples as they're coming into the lab. Another big challenge that we had over there that we have never had in any other place is how the samples are transported from the site. It's a big site and has the automated sample transport system that actually brings the samples together into a central lab. The challenge again over there is that we are talking about building interfaces now. So you have a third-party EPC that's building the transport system to bring the samples into the lab. How do you do that? So this is where the interfaces are developed using the bus architecture versus just connecting via point to point. So that makes up the quality operations management piece of the functionality. As I talked about, the third one, which is really the heart of the MOM architecture, is the production operations management system. And now production operations management, which is basically the piece that you see here in the middle, both of them reside both in the MOM layer and also in the ERP layer. So the entire process starts with the release of a production order, and when it comes down to the MOM layer, there is an order execution module that actually manages the end-to-end production cycle. It would take the order, it would split the order, and manage the execution of the order throughout the manufacturing life cycle. Production would do whatever they need to do, and it would report the batch and the production results back into the ERP production planning module. We have functionality in place that actually stores the operating parameters and allows the easier interface for the users to maintain the recipe, and also allows them to download it to the control system. There is a fully enabled, and we heard a lot today about the alarm and event management. There's a fully enabled alarm and event management module that connects to the IPCS and also resides on the MOM layer, which allows the traceability of the alarm, the enforcement of the alarm, and archiving of the alarms. So those are some of the key elements that makes up the production operations management piece. The fourth piece is the regulatory compliance management, and this basically is made up of two big modules. The challenge over here was that we had solutions that worked, but they were largely disconnected, and we didn't have the interfaces, again, built to the ERP system to report the compliance results, both in the emissions tracking and the on-site hazardous waste disposal. So here's where we had built the interfaces, again, using the manufacturing enterprise bus architecture to get the emissions directly out of either the historian or or from the analyzers or from the devices on the floor, and then report the data back into the ERP system. And the fifth and the last big module is basically the most complex one, at least for us, because we didn't have the leverageable solution, neither or we have a site quite like this in the Dow enterprise today. I mean, there are sites that are bigger, actually. We have sites in Germany or in Freeport. It's bigger, but nothing is disintegrated. And we didn't have quite the knowledge of leveraging a solution that allows us to do the inventory operations management quite the way it's required over in Saudi Arabia. So the inventory operations management, which has been our biggest challenge, we had simplified into 3 modules, if you will. One is the packaging center operations management, you see to the right here, which is basically made up of the liquid center, the solid center, container marshalling yard, central dispatch, and drop and swap. This is where they perform the outbound and inbound deliveries, bagging and drumming, and of course it's a place where they do the inventory management for the material. The upstream units sends the material for storage and bulk loading, and all that happens is in the packaging center. Things that we've heard today about the different technologies that enables this kind of solution is actually deployed here. We were talking about a highly sophisticated warehouse, basically, and we're going to have forklifts with the mobile equipment loaded, on them, and then heavy transaction because of the volume of material that would go through there. So it's a complex piece of operations when it would be up and running. The second one is the site integrated planning and scheduling software that actually does the production planning and the scheduling for the entire site. It's also highly integrated. It integrates with the packaging center and also up to the ERP, and that is the piece that would actually allow the scheduling communication to go back and forth with the ERP system and within the MOM layer. And then the third piece, which is not really in the scope of work that we are doing, but it is sitting right in the MOM layer, is something called terminal management system. And that piece of that software is extremely important to the site. It's going to manage the material transfer between the plant and the tank farm and the packaging center and to the port. Our challenge is to integrate that solution into the solutions that we've had in the MOM layer. So the integration between the packaging center, the site integration planning and scheduling, and the terminal management system is all done predominantly through the bus or the vendor-provided interfaces. So that's at the high level, the challenges that we've faced and what are some of the big modules that are in place. Our big challenge was to make all of this stuff kind of come together in a very short amount of time. We started doing the gap fit analysis about a little over a year ago, and last weekend is when the first implementation actually did happen. So this is no longer a concept. Several of the key modules that I talked about, so the operator rounds, red tag management system, reliability analytics, scheduling, quality operations management, so the LIMS system and its related module, they're all in production and ready to support the plants that are coming up. The assets are coming up one plant at a time, if you will, or they would go through the pre-commissioning, commissioning, mechanic, and a startup. And as the assets are turned over from EPC to the site, they would start using the systems and start converting the work processes from EPCs to the Sadara work processes, and actually start using the systems. The systems are fully integrated in the manner that it supports the work processes and the business process hierarchy that I described earlier. So with that, Greg, I think that's my presentation.